the lesson, it will give you 3 examples of solving an exponential equation when it's not possible to write both sides of the equation as exponents with the same base. So this is an example here where you can see that it would not be possible to write 24 as a power of 5 so that it could match up with that other side. So what we're going to do is take the log of both sides, because what that will allow us to do is, with our properties of logarithms, we'll be able to bring that exponent down in front, and then the x will be freed up and we can solve for it. Now you can use log with any base that you choose, so you could use the natural log if you would like. That's what the textbook uses. I noticed the answers in the answer key are all using log base 10, so that's what I'm going to use, just so you're used to seeing that. Okay, so again, what I'm going to do is, I can do this because of lots of algebra. I'm going to take the log of both sides. Okay, don't forget to do both sides of the equation so that we keep the equation balanced. So we have the log of 5 to the x plus 1 equals log of 24. And now, again, using our powers or our rules for logarithms, we know exponents can come down in front and act as multiplication. So I have x plus 1 times the log of 5 equals the log of 24. We want to solve for x, so we're going to have to distribute, and this gets a bit confusing, so make sure you write really clearly for yourself. Just remember, log 5 and log 24, those are just numbers. Okay, they're just numbers. They look a little more crazy because they have log there, but they act the same way as any other real number. So if I distribute that, I get x log 5 plus the log of 5 equals the log of 24, and I just distribute it into those parentheses. Now, just like with any other equation, we want to isolate our variable x, so I need to move anything that doesn't have an x in it to the opposite side, which means I'm going to subtract log 5 from both sides of the equation. Now I have x times the log of 5 is equal to log 24 minus log 5. And my last step is to divide both sides by the log of 5, because it was x times log 5. So to remove that and move it to the other side, I have to do divide. So my answer is x equals, and I'll put my parentheses like I should have the whole time, the log of 24 minus the log of 5 divided by log 5. Now if we wanted to find the decimal answer, we would just put that into our calculator and then use rounding. However, this is our exact answer for this problem, log 24 minus log 5 divided by log 5. Okay, here is the second example. So again, we can see that we have 2 to a power and 5 to a power. There's no way we can write 2 and 5 with the same base. So our other option is to use logarithms. And again, we start by doing the log of both sides. Again, you do have the option of using natural log if you would like to. But in this case, when you have real numbers you're using, it really doesn't matter. Okay? Okay, now the reason we did this is so we could get those x's out of the exponent. So we use our properties of logarithms that tells us that we can bring those exponents down in front. So I have x plus 1 times the log of 2 equals x times the log of 5. Okay, we're solving equations, so first thing we want to do here is remove the parentheses by distributing. So I have x times the log of 2 plus 1 times log 2, which is just log 2, equals x log 5. The next job when we're solving an equation is to get the x terms on the same side. So notice we have x log 2 here and x log 5 here. I'm going to subtract, x log 2 from both sides. Notice I'm subtracting and not, it almost looks like I'm dividing there because of my... Okay, so now I have the log of 2 is equal to x times the log of 5 minus x times the log of 2. I can go ahead and factor out an x. Now that I've gathered my x's together, I'm going to pull an x out of each term, and I'll have log 5 minus log 2. I want to isolate the x, so I'm going to go ahead and take that last step. I'm going to divide both sides by log 5 minus log 2 so that the x will be all alone there. Okay, so I'm going to do the same thing over on the other side. And I have my answer. I now have x completely alone on one side of the equation. So my answer is x equals log of 2 over log 5 minus log 2. Okay, and those are all base 10. And there is my exact answer. Like I said, if they wanted a decimal answer, I could use my calculator to find the log of 2, log of 5, and find that exact answer. All right, here is our last example here. And depending on which textbook and which thing you use, they might do some more simplification on these problems. But I'm just going with what's required in the class and what they did when they made the answer keys. So here we go. Again, we can't write 1/3 and 2 in the same base. There's no possible way to do that. So instead, we're going to use logarithms to solve this problem. So we are going to take the log of both sides. And again, the reason we're taking the log of both sides is so that we can get those x's down out of the exponents and actually solve for them. So using rules of logarithms or properties, we know we can bring those exponents down in front. I'm going to try to write as neatly as I can so we have enough room. So now I have x plus 1 times the log of 2 equals x plus 4 times the log of 1/3. I need to remove the parentheses, so on both sides I'm going to distribute to remove parentheses, and I'll have x log 2 plus log 2 equals x times the log of 1/3 plus 4 times the log of 1/3. At this point, I want to gather all of the x's on the same side, and I also want to move anything that doesn't have an x to the other side. And just to conserve room, I'm doing this all in one step. So you just make a choice which direction you want to go with your x's. I'm going to subtract x log 1/3 from both sides, okay, so that I can move anything with an x. It looks like I'm moving to this left-hand side. Okay, so that would cancel that. I'm also going to move this log 2 over to the right-hand side because it doesn't have an x. I don't want it over there. And again, you can do this in 2 separate steps, but I'm just trying to save room on the page because it's kind of hard to write on this screen. So what do we have left? We have x log 2 minus x log 1/3 equals 4 log 1/3 minus the log of 2. Okay, now we need to get that x alone, so we're going to factor an x out on this right-hand side so we can totally isolate the x value. And our last step now is to divide both sides by log 2 minus log 1/3 because that was multiplied by our x. And our x will be totally free and clear, and we have solved for x. Our answer is x equals 4 times the log of 1/3 minus the log of 2 over log 2 minus the log of 1/3. And there we have our answer. It doesn't look real simplified, but that would be our exact answer in logarithmic terms. If we wanted to write the answer as a decimal, like I said, you would just take out your calculator and figure out what that decimal number would be.